Occurrence of metals. The Earth's crust is the major source of metals. Seawater contains some soluble salts such as sodium chloride, magnesium chloride. The elements or compounds which occur naturally in the Earth's crust are known as minerals. At some places, minerals contain a very high percentage of particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Extraction of metals. So you have learned about the reactivity series of the metals. Having this knowledge, you can understand how a metal is extracted from the ore. Some metals are found in the earth crust in the free state. Some are found in the form of the compound. The metals at the bottom of the activity series are least reactive. They are often found in free state. So for example, gold, silver, platinum and copper are found in the free state. Copper and silver are also found in the combined state as their sulfides or oxide ores. The metals at the top of the activity series, potassium, sodium, calcium, magnesium, aluminum, are so reactive that they are never found in the nature as free elements. The metals in the middle of the activity series, zinc, iron, lead, are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides or carbonates. So you will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the earth. Thus, on the basis of reactivity, we can group the metals into the following three categories: metals of low reactivity, metals of medium reactivity, metals of high reactivity. Different techniques are to be used for obtaining the metals falling in each category. So for example, potassium, sodium, calcium, magnesium, aluminum. So technique is electrolysis. Zinc, iron, lead, copper means medium reactivity, reduction using carbon. Then silver and gold found in native state means in the free state. So several steps are involved in the extraction of pure metal from the ores. A summary of these steps is as given below. Each step is explained in detail in the following section. So for example, there is a ore and there is a first is the concentration of ore, means that is the washing and magnetic separation. So metals of high reactivity, they are doing the electrolysis of molten ore, we get the pure metal. Then metals of medium reactivity, it are found in the carbonate ore as a sulfide ore. Then we have to convert first into the oxide of metal, then carbonate ore, calcination without heating in absence of air, that is known as calcination, and roasting, heating in presence of air, that is the roasting, and we get the oxide. Then on reduction to metal with the help of carbon, so then is the further is the purification of metal. Metals of low reactivity are found in sulfide ores, and on roasting we get the metal simply by the procedure, that's oxide, then the reduction of the metal, we get the metal, and then refining, that is the purification of metal. Then enrichment of ores. The ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the gangue from the ore are based on the difference between the physical or the chemical properties of the gangue and the ore. So different separation techniques are accordingly employed. Extracting metal low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar HgS is an ore of mercury. When it is heated in air, it is first converted to mercuric oxide. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper is found as the copper sulfide in nature and can be obtained from its ore by just heating in air. So we get the oxide with copper sulfide gives you copper and sulfur dioxide. Then extracting metals in the middle of the activity series. The metals in the middle of the activity series such as iron, zinc, Lead, copper are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxide. The sulfide ores are converted into oxides by heating strongly in presence of excess air. This process is known as roasting. The carbonate ores are exchanged to oxide by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores is as roasting. So zinc sulfide on heating in presence of oxygen gives you zinc oxide and sulfur dioxide. Calcination on heating in absence of air gives you zinc oxide and CO2. The metal oxides are then reduced to the corresponding metal by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. So you are already familiar with the process of oxidation and reduction. So obtaining metals from their compounds is also a reduction process. So besides using carbon coke to reduce metal oxide to metal, sometimes displacement reaction can also be used. The highly reactive metals such as sodium, calcium, and aluminum are used as reducing agents because they can displace metals of low reactivity from their compounds. For example, when manganese dioxide is heated with aluminum powder, the following reactions takes place. So manganese oxide. So this is the manganese dioxide plus aluminum gives you manganese plus aluminum oxide plus heat. So these displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals are produced in the molten state. In fact, the reaction of iron oxide with aluminum is used to join railway tracks or cracked machines. This reaction is known as Thermit reaction. So this reaction is known as the Thermit reaction. Extracting metals towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminum to the respective metals. This is because these metals have no affinity for oxygen than carbon. So this is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, that is the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. The reactions are, so cathode is the reduction, anode here is the oxidation. Similarly, aluminum is obtained by the electrolytic reduction of aluminum oxide. Then refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Electrolytic refining, many metals such as copper, zinc, nickel, silver, gold are refined electrolytically. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. The solution of metal salt is used as an electrolyte. On passing the current to the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud.